supported beam AP 6 meter long is loaded as shown in figure. Full stop. Draw the shear force and bending moment diagram for the beam and find the location and maximum bending moment. That A and B it is simply supported beam and UDL load it is given A to C and D to B. Okay. So first of all, to find the reaction of the beam, find reactions of the beam, find reaction of the beam, find the reaction of the beam. Okay. So there will be some assumption. If the moment it will be clockwise, then it will be take positive. If the moment it is clockwise, it will be take positive. If the moment it is anti-clockwise, then it will be take negative. The moment it is anti-clockwise, then it will be take negative. The force it is going upward, it will be take positive. Force it is going downward direction, it will be take negative. For upward it is positive. For downward it will be negative. Okay. Negative. Negative. Okay. So first of all, take moment at summation of MA is equal to 0. Summation of MA. We apply the equilibrium equation, that is summation of MA is equal to 0. Summation of MA is equal to 0. Okay. So we need to take moment at A is equal to 0. All the forces will be take moment at A is equal to 0. Okay. So first of all, convert this UDL load it is in point load. Okay. Convert this UDL load it is in point load. So for UDL load, so this one it will be converted it is in point load. Okay. So this UDL load it is 4 kN per meter. So we need to convert it is in kilonewton. Means 4 into 1.5. It will be 6 kilonewton. So 6 kilonewton it is acted where? At the center of this A to C. 6 kilonewton it is acted at the center of AC. At the center of AC means it is 0.75 from the A. 0.75 meter from the A and 0.75 meter from the C. Okay. It will be this distance, it will be 0.75. Okay. This distance it will be 0.75 and this will be also 0.75 meter. Okay. The second point load it is, second UDL load it is, this is 2 kilonewton per meter. So 2 kilonewton per meter converted is in kilonewton. Okay. So 2 kilonewton per meter it is acted over the span D to B. So 2 into 3. So D to B distance it is 3. That's why 2 into 3 will be 6 kilonewton. 6 kilonewton is acted D to B of center. D to B of center means it is 1.5 meter from A and 1.5 meter from B. So that is it will be acted here. Okay. So this one it is also 6 kilonewton. 6 kilonewton. 6 kilonewton. Okay. So now apply the equilibrium equation. So first it is 6 kilonewton is how it is rotating about the point A. Just see, this one it is rotating about the point A, it is in clockwise direction. The rotation, this one it is clockwise direction. So 6 into 1.5. 6 into it will be 6 into 0.75. 6 into 0.75. Then second UDL load it is this 6 kilonewton. It will be also rotating in clockwise direction. So 6 into, so perpendicular distance it is this perpendicular distance it will be 1.5. This one it will be, so this distance it is also C to D, it will be also 1.5 meter. 1.5 meter. So this distance it is also 1.5. So 6 minus 1.5 minus 3, it will be get 1.5 meter. So 6 into 1.5 plus 1.5 and this 1.5. It will be total 4.5 meter. 4.5 meter. 4.5 meter means A to E distance it is 4.5 meter. Hence, third one force it is acted also at E, it is 5 kilometer. So 5 into, so this distance it is also 4.5 meter. A to distance it is 4.5. So this one it is also rotating about the point A, it is clockwise direction. Here, how it is rotating about the point A, it is also clockwise direction. So that's why it is plus. Then minus RB. RB it is rotating about the point A, it is anti-clockwise direction. So RB into the total distance is 6 meters is equal to 0. Here RB, how it is rotating RB about the point A. Here this one it is RB, it is rotating about the point A, it will be anti-clockwise direction. Okay, it will be rotating anti-clockwise direction. Okay? So this rotation it is anti-clockwise direction. So that's why it will be minus. From this relation, it will get reaction of the B. Okay, just calculate reaction at B. So RB is equal to 6 into 0.75 and plus 6 into 4.5 and plus 5 into 4.5 divided by 6. It will be 9 kilonewton. So RB it is 9 kilonewton. So reaction at B it is 9 kilonewton. So RB is equal to 9 kilonewton. Then second equilibrium equation applies, summation Fy is equal to 0. Algebraic sum of all the vertical forces is equal to 0. Summation Fy is equal to 0. Summation Fy is equal to 0. Okay. So first it is RA, it is going upward, so that's why it is plus. Then minus this 4 into this 4 kilonewton per meter. 4 kilonewton per meter, this UDL it is converted, it is in point load, that is 6 kilonewton. Then third one, it is also this 2 into 3, it will be 6 kilonewton. It is also downward direction. Then minus 5. Then plus RB, it is going upward, which is RB is equal to 0. Is equal to 0. Okay. RB is equal to 0. So just simplify this. So RA minus 6 and minus 6 minus 5. Then RB it is going upward direction. Plus 9 is equal to 0. Is equal to 0. So RA is equal to so minus 6 minus 6 minus 6 minus 5 plus 9. Okay, so it will be minus 8 kilonewton. If you will take right side, so it will be positive 8 kilonewton RA. So RA is equal to this 8 kilonewton. RA is equal to 8 kilonewton. RA is equal to 8 kilonewton. Okay, so we are calculating the reaction of this beam in first step. The next step it is SF calculation. Do the SF calculation. Okay, so RB is 90. RB is equal to 9 kilonewton. 9 kilonewton. So step number 2, SF calculation. Shear force calculation. Shear force calculation. Okay. Shear force calculation. So SF at left of A. We start from SF at left of A. SF at left of A, there is no any force in left side. Okay. Left of A it will be, there is no any force. Here this one it is A point. In the left side of A, there is no any force. That's why it will be 0. 0. Okay. Then next SF at A. SF at A it is 8 kilonewton. It is going upward direction. So upward direction it is positive value. So it is 8 kilonewton. Then next SF at left of C. SF at left of C or at C. Okay, or at C. So these two value it will be get same. Left of C and at C it will be get same value. Okay. So 8 it is going upward direction. That's why plus, then minus this 4 into 1.5. So this one it is going downward direction. 4 into 5 it will be 6 kilonewton. So this 6 kilonewton is going downward direction. Okay. Here this 6 kilonewton is going downward direction. That's why it is minus 6. Okay. So it's the left of C and at C it will be 2 kilonewton. 2 kilonewton. Okay. Then SF at left of D. SF at left of D and at D and at D. So this it is also get the same value. If it is left of D and at D, it will be get same value. Okay. So SF at left of D and at D it will be, first it is 8 kilonewton, it is upward. Then this one it is minus 6. Means it will be 8 minus 6. So that's why it will be also 2 kilonewton. 2 kilonewton. Okay. Then SF at left of E. SF at left of D. SF at left of D. Sorry, the SF at left of E. So SF at left of E. So this one 8 it is going upward direction. Then this 6 it is going minus downward direction. Then this 2 into it will be acted left of C. How much distance this one? This distance it is 1.5. 1.5. So 2 into 1.5 will be 2 into 1.5. It will be 3 kilonewton. So 3 kilonewton is going downward direction. Okay. Left of this usual load, it is up to 1.5. So 2 into 1.5 will be 3 kilonewton. Okay. So this one it is active 3 kilonewton. It is downward direction. So minus 3, then minus 3. Okay. So it will be get shear force at left of E. Okay. So 8 minus 6 minus 3. It will be minus 1 kilonewton. Minus 1 kilonewton. And SF at E. SF at E. SF at E. It will be this minus 1. Then at E it will be 5 kilonewton downward force it is active. 5 kilonewton this downward force it is going. This force it is going downward direction. Okay. So this force it is going downward direction. So that's why it will be minus 5. Minus 5 is equal to it will be at E minus 6 kilonewton. Minus 6 kilonewton. Okay. Then next SF at left of B. SF at left of B. Left of B. SF at left of B it will be first it is 8 kilonewton is upward, then minus 6 kilonewton is going downward, then 2 3 is 6, this one it is minus 6 it is also going downward, then minus 5 minus 5 minus 5 is equal to SF at B it will be 8 minus 6 8 minus 6 minus 6 minus 5 it will be minus 9 kilonewton minus 9 kilonewton minus 9 SF at left of B. Now SF at B. SF at B. SF at B is equal to so this minus 9 kilonewton. So RB at B it will be reaction it will be going upward direction. Okay, it will be going upward direction. So that's why it will be plus 9. So it will be get 0. Okay. So now this one it is SF calculation. Now draw the shear force diagram with the help of SF. Okay. So first of all draw the reference line. So first at the A this line draw, then at C, then at C, then at D, then at D, then at E, then at E, then at B, then at B. Okay. Then draw the neutral axis. This is neutral axis of SFD diagram. Okay. So first of all, SF at left of A it is 0. Okay. So this one it is A point. Okay. This one it is A point. Okay. So SF at left of 8 is 0. So SF at 8 is 8 kilonewton. So this one it is 8 kilonewton. 8 kilonewton. So that is 8 kilonewton. So next, SF at left of C. SF at left of C or at C it is 2 kilonewton. Okay. It will be 2 kilonewton. So 2 kilonewton at left of it is there. 2 kilonewton. Then SF at left of D it is also 2 kilonewton. SF at left of D or at D it will be also 2 kilonewton. Okay. This one is 2 kilonewton. Then SF at left of E it is minus 1 kilonewton. So this one it is minus 1 kilonewton. Here it will be minus 1. Okay. Then next SF at E. SF at E will be this minus 1, then minus 5 will be minus 6 kilonewton. Minus 6 kilonewton. Then SF at left of B is SF at left of B is minus 9 kilonewton. So this will be minus 9 kilonewton. Minus 9 kilonewton. Then SF at B it will be 0. So minus 9 plus 9 it will be get 0. Okay. So this one it is 9 kilonewton. So this one it is 1 kilonewton minus 1. So this one it is 2 kilonewton. Okay. So this one it is SFD in kilonewton. SFD in kilonewton. SFD in kilonewton. Just add the line SFD portion. So this one it is SFD diagram in kilonewton. So above the neutral axis it will be positive, and below the neutral axis it will be negative value. So SFD all these value it is in kilonewton. This is SFD diagram. SFD SFD it is in kilonewton. Okay. Kilonewton. So now next step it will be do BM calculation. BM calculation. Next step BM calculation. Okay. So step number 3. Okay. BM calculation. BM calculation. This one is 9. 9. So BM calculation. BM calculation. BM calculation. So BM calculation. Here it will be one assumption. When if it is point D, if you are taken right side or left side, okay, movement, if you are, suppose if you are taking left side movement, means left side, D of left side, so anti-clockwise, clockwise it will be take positive. If it is left, right, left side, so it will be take positive, clockwise movement, okay, and anti-clockwise it will be take minus. So this assumption for the bending movement when it is left side, and it is left side. Okay, if the point it is, if the moment it is left side of this point, it will be take this assumption. If it is right side, then it will be take vice versa. Anti-clockwise it will be take negative, and clockwise it will be take positive. Clockwise it will be take clockwise it will be take negative, and anti-clockwise it will be take positive. Anti-clockwise it will be take positive, and right side. Right side. Okay, right side. Okay, so this one it is assumption for the bending moment. Okay, so now BM calculation. BM at A, BM at A, BM at A is equal to 0. BM at A is equal to 0. The next it will be BM at C. BM at C. So BM at C, it will be take load of total load of right side. Okay, so that's why we need to do the assumptions of this left side. Okay, so all the forces of C of left side. Just see which how much loads it is left side of load, left side of C. So there is only 2 loads. So that's why you take left side. So BM at C. So this one it is 8 into 1.5. 1.5 force into perpendicular distance. So it will be rotating about the A, it will be clockwise direction. Okay, it is rotating about the A, it is clockwise direction. See here how it is rotating. It will be at point C. It is in clockwise direction. Okay, see here this one it is rotating clockwise direction. So that's why it is plus. Then this 6 kilonewton is the actual center of this UDL load. That is means how much this distance, it will be 0.75. So this distance it is 0.75 from C. Okay, so it will be how it is rotating about the C. This one it is rotating about the C. It will be anti-clockwise direction. Okay, it is rotating anti-clockwise direction. So that's why it will be minus 6 into 0.75. Minus 6 into 0.75. So BM at C it will be get BM at C 8 into 1.5. 8 into 1.5 minus 6 into 0.75. Minus 6 into 0.75. 0.7. That will be 7.5 kilonewton meter. 7.5 kilonewton meter. Okay. So all the forces of C we are taken left side of C. Okay. That's why it will be, we are done assumption left side assumption. That is clockwise plus anti-clockwise it will be minus. Okay. Then next BM at D. BM at D. BM at D. It will be also take clockwise left side load. Okay. There is only 2 loads in left side. Right side there are 1, 2. This one it is. So left side of D it will be only 2 forces. It will be take BM at D it will be 8 into perpendicular distance up to D it will be A to D distance, it will be 1.5, 1.5, it will be 3 meters. It will be rotating about the point A. Sorry, point E. How it is rotating? Here, this 8 into this one, it is rotating about the point D, clockwise direction. Okay, that's why it is positive. And second one, it is this is 6 kilonewton. It is rotating about the point D in anti-clockwise direction. So what distance? This one is 0.75 plus 1.5. 0.75 plus 1.5. So minus 6 into 0.75, 0.75, 0.75 plus 1.1 plus 1.1, 1.5. Okay. That will be get BM at D. So BM at D will be 8 into 3, 24 minus 6 into 0.75 plus 1.5. Okay. So it will be 10.5 kilonewton meter. 10.5 kilonewton meter. 10.5 kilonewton meter. Okay. So this one it is BM at D. So now BM at E. BM at E. So just take BM at E. BM at E. BM at E is equal to. So first of all, so BM at E, it will be take right side, all the forces to right side. Okay, it will be take all the forces of right side. So we need to assumption this one. Okay, so clockwise it will be minus, anti-clockwise it will be plus. So BM at D. Why we are taken right side loads? Because there is only two forces in right side. And left side there are this one 1, 2 and 3. So it will be get more time. Okay, that's why we are taken left side, right side loads. Okay, right side of E. So BM at E, right side of E, how it is rotating this B point about the E. See here, this one it is how it is rotating about the point A. It will be anti-clockwise direction. So that's why it will be plus. So 9 into perpendicular distance about the E, it will be 1.5. 1.5. 9 into 1.5. 9 into 1.5. Then next one it is this usual load. Usual load it is up to the 2 into 1.5. 2 into 1.5 will be 2 into 1.5. 2 into 1.5. It will be 2 into 1.5. So this one it is 3 kilonewton. 3 kilonewton is acted at the center of 1.5. This 3 kilonewton is acted center of 1.5. Center of 1.5 means it will be 0.75 meter up to E. 0.75. So the distance it is 0.75. 0.75. Okay. So minus. So this rotating about the point A. How it is rotating about the point A, it will be clockwise direction. So here clockwise it will be negative. Clockwise it will be negative. So that's why 3 into 0.75. 3 into 0.75. It will get bending moment at E. So 9 into 1.5, then minus 3 into 0.75. It will be 11.25. Bending moment at E, 11.25 kilonewton meter. Okay, so you can take left side load also. It will be get same answer, but it will be take more time for calculation. That's why I have taken right side load of E. Okay, that's why it will be get less calculation. It will take less time. Okay, that's why we have taken right side load. Okay, so it will be 11.25 kilonewton meter. Now calculate location of maximum bending. Location of maximum bending. Okay, location of maximum bending. Okay. Location of maximum bending. We need to location of maximum bending moment. Maximum bending moment. Location of maximum bending moment. So we need to do the similar triangle. So this one it is 2 kilonewton and this one it is 1 kilonewton. Okay. So we need this distance. We need to calculate this distance. That is x distance. So just assume this one it is x. Okay. This distance is x. So up to D to E. So the distance it is total distance it is 1.5 meter. So this distance it will be 1.5 minus x. 1.5 minus x. 1.5. So apply the similar triangle. So 2 divided by 1.5 x divided by 1. X divided by 1, x divided by 1, x divided by 1, x divided by 1 is equal to a similar triangle x divided by 1, then 1.5 minus x, 1.5 minus x divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. Okay. So it will get this x value. Just simplify this one. So 1 into, so 2 into x, it will be 2x, 2x. Then 1 into 1.5x minus 1. Okay, so 1 in bracket 1.5 minus x. Just cross check, just do the cross check, cross multiplication. X into 2, 2x. So 1 into in bracket 1 minus 1.5 minus x. So x will get x value form. X value is equal to we will get how much? The x term it will be take one side. So 2 minus 2. So 2x minus x it will take left side. So 2x plus x it will be 3x. 3x divided by 1.5 divided by 3x. That is 3. It will be 0.5. X is equal to 0.5. X is equal to 0.5 meter. X is equal to 0.5. So this distance it will be x is equal to 0.5. So location of maximum bending moment where? Maximum bending moment at what distance? So this distance it is 0.5. 0.5, then up to it is 0.5. 0.5 plus 1.4. So 2 meter at 2 meter from B. At 2 meter from B. At 2 meter from B. Okay. At 2 meter from B. Okay. So maximum bending moment is at 2 meter from B. Okay. So now calculate maximum bending moment. Where it will be maximum bending moment? Here, this one it is maximum bending moment. It will be this one. It is maximum bending moment. Okay. So it would be 2 meter from B. 2 meter from B. 2 meter from B. Just calculate maximum bending moment. Maximum bending moment. Maximum bending moment. Okay. Maximum bending moment. M max is equal to here. So this RB is going, how it is rotating? We are taking left side load. Okay. So take right side load. Right side of this section means it will be clockwise it is minus, anti-clockwise it will be plus. So RB it is 9 kilonewton. 9 into 2 meter. 9 into 2. So this distance it will be 2 meter. This distance it is 2 meter. 9 into 2. How it is rotating about here? It is anti-clockwise. So anti-clockwise it will be plus. Then minus. Then this 2 kilonewton load it is how it is rotating. 2 kilonewton load it is 2 into it's converted in first point load 2 into 1. Okay, distance it will be acted into the center of here. Then minus this 5 into 0.5. 5 into 0.5. Okay, so this one how it is rotating E load it will be clockwise direction. So clockwise it will be minus. Then this 2 kilonewton per meter is acted over the 2 meter. So 2 into 2, 4. 4 meter where it will be acted? 4 meter is acted center of 2 meter. That is center of 2 meter. Okay. This 4 kilonewton will be acted center of 2 meter. That is means 1 meter from the maximum bending. So that's why it will be 2 into 2 into 1. So it will get maximum bending moment is equal to 9 into 2, then minus 4, then minus 2.5. It will be 11.5 kilonewton meter. Maximum bending moment it is 11.5 kilonewton meter. Okay. So just draw the bending moment diagram. Okay. bending moment diagram. So first of all, draw the reference line for that. The reference line. So at A, this reference line. At C, it will be this reference line. At D, it will be this reference line. And location of maximum bending moment, this one. The bending moment at E, it will be this one. And at B, this one, reference. Okay. So now, draw the bending moment. So this one it is. This one it is neutral axis of this bending moment. Okay. So first of all, bending moment at C. Bending moment at C we are calculated it is 7.5 kilonewton. So draw the parabolic line. Under the UDL load, we need to draw the parabolic line. It will be 7.5. Bending moment at C will be 7.5 kilonewton. 7.5 kilonewton meter. Then bending moment at D, it will be straight. Okay. So bending moment at D, it will be how much? 10.5 kilonewton. 10. So bending moment at D is 10.5 kilonewton. 10.5 kilonewton. 10.5 kilonewton. It will be straight line. So then bending moment at maximum bending moment it will be 11.5. So just draw this one. It is parabolic line. 11.5 kilonewton meter. 11.5 kilonewton meter. This one it is 11.5. So maximum bending moment it is 11.5 kilonewton. Then bending moment at E is 11.25. 11.25 will be 11.25. So this one it is also parabolic. 11.25. Okay. So then bending moment at B will be 0. Bending moment at B will be 0. Okay. So we are not done calculation, but it will be 0. At the support it will be 0. So this one is BMD diagram. Okay. BMD diagram in kilonewton meter. Kilonewton meter. So BM at D it will be calculated 10.5. 10.5 kilonewton meter. So BMD in kilonewton meter. BMD in kilonewton meter. Kilonewton meter. BMD in kilonewton meter. So this value is positive value. Why? So bending moment it is sagging type bend offer. So that's why it will be plus. Okay. So BMD in kilonewton meter. It is positive value. So this one is plus. Why it will be plus? Because it will bend sagging type bend offer. Sagging top bend offer. Due to external load, when the beam it is simply supported. Here. This it is simply supported beam. When you apply force external on that beam, it will be bent sagging type bend. So this one it will be called sagging bending moment. At A and B it will be support. There will be two support at corner. Okay. So when we apply external force on that book, it will be bent sagging type bend. So sagging bending will be considered as positive. Okay. So that side is plus. So this one it is SFD BMD diagram for the given loading line. Given simply supported beam. Okay.